I'm Ravi Kiran. So now I would like to say something about batteries. So in the previous class we had discussed the electrical installation. So one of the part this is that batteries. So in the previous class we had discussed the electrical installations, that is LT components, low tension components such as like SFU switch fuse unit, MCB, MCCB, and ELCP, earth leakage circuit breaker, types of batteries, types of cables. So these are the first part. And in this electrical installations, second part is nothing but batteries. So in the last class we had discussed some of the topics in the batteries, that is primary batteries, secondary batteries, battery characteristics, and etc. etc. So in the previous class we had remembered that what is battery. So battery related to chemical energy into electrical energy, similarly motor, generator, transformer. So similarly the motor, battery is nothing but chemical to electrical energy, so it converts chemical energy into electrical energy. Similarly the motor is electrical energy is converted into mechanical energy. And generator, so here the generator is nothing but mechanical energy is converted into electrical energy. So whereas the transformer is nothing but so it is the principal Faraday's laws of electromagnetic induction. Okay, so that next coming to point here. So today we will discuss the about batteries. So batteries, in batteries, power factor improvement methods, so efficiency, so whatever it is, extra, etc., etc. Okay, next. So in energy consumption, so here the energy consumption in an electrical installation is calculated by that multiplying the power rating of devices. So that power rating in devices it is in only watts by the time they are used in hours only. So it is divided by 1000 to obtain kilowatt hours. Okay, so to get the total consumption, sum of the kWh of all appliances. So these are the energy consumption in battery systems. So what he's saying here, the energy consumption in an electrical installation. So in an electrical installation is calculated by the multiplying power rating. So that too power rating in only watts. So the power units is nothing but watts. So by the time they are used in hours only, not seconds, minutes. So it is used in only hours. So it is divided by 2000 to obtain the kilowatt hours. So to get the total consumption, sum of the kWh of all appliances. So how do the calculations here, the steps for calculation. So first identify the power rating. Next determine usage time. Next convert to kilowatts. So these are the steps. So here the first one I'm taking, identify power rating. So how to identify the power rating? So find the wattage on the appliances label. If an any equipment is there, so in the equipment or on the equipment, so find the wattage on the appliances label. So this is the one of the method steps for calculation. Second one, determine usage time. So how to determine the usage time? So first record how many hours the device is operates daily. So this is one of the steps for calculation. So determine usage time. So first so the equipment on and off position. So suppose on position, so in the on position record how many hours the device operates in a daily. So that is one of the steps for calculation. in the determined usage time. Next, convert to kilowatts. So convert to kilowatts, divide watts by to get kilowatts. So this is the steps per calculation per energy consumption. Okay, so here there are so many steps. So but here I'm taking few steps only, that is identify power rating, determine usage time, and convert to kilowatts. So here the basic formula of the electrical energy is consumed given by, so basic formula of the batteries. Here let us see that energy is equal to, so that energy in kWh, kilowatt hours, is equal to power kW into time. So before I told the time is taken, it will be only hours. So hours here, so the power is equal to time into time, power into time. So energy next energy, so the energy kilo hours, energy in kilo hours is equal to power into time. So here the unit of energy, here the for the units of energy, kilowatt hours. For 1 kilowatt hour is equal to 1 kilowatt hour is equal to 1 unit. As per electricity billing, what you are getting the electricity bills. So as per that electricity billing, 1 unit, 1 kWh is equal to 1 unit as per electricity billing. Okay, so these are the basic formula of electrical energy consumed given by the energy. Next, step by step calculation. So how to calculate the energy? Here the step 1, convert power to kilo power. So see here, first one, convert to power to kW, kilowatt power in kilowatt is equal to power in watts, 1000. Okay, so power in kilowatts is equal to also 1000. Power in kilowatts is equal to 1000 watts. So basically here the power units watts. Okay, and the next step 2. Here the step 2 is nothing but multiply the time, multiply by time. Step 2, multiply by time. So here the multiplied by time is energy is equal to power into time. So here two steps I taken here, two steps. The two steps is nothing but first one, convert power to kilo power. Next step 2, multiply by time. So these are the step by step calculation in energy consumption. Okay. Next battery backup. So battery backup, elementary concept and calculations. So here the battery backup, so many ways. So what are the so many ways battery backup? So first one, battery backup. Let us assume battery backup, UPS, uninterrupted power supply. Next, second one, solar power panel, solar power. Third one, here the so many ways, UPS, solar power. Next, DG set. Here DG is nothing but diesel generator. Okay, so DG set. So these are the battery backup. Battery backup, here the so many ways: UPS, uninterrupted power supply, solar power energy, solar power panels, and DG set, diesel generator, and one more thing: inverter plus battery system. Inverter plus battery system. So these are the battery backup. So battery backup, we are taking so many ways. So the so many ways in that first one: UPS, uninterrupted power supply, UPS. So when the supply is fails, or main supply is fails, when we are taking that UPS. So the UPS is nothing but inverter, DC to AC, the conversion of DC to AC. So here the solar panel, so sunlight energy into electrical energy. Next, DG set. So he basically here the DG set is used in the schools, offices, hospitals, theaters, so many ways, so many, etc., etc. So these are the battery backup ways. Next, elementary concept and calculations. So basically, elementary concept calculations. Before going that, battery backup is used to supply power during the power failure. It depends on load, battery, and capacity and efficiency. So these are the battery backup. Next, basic formula for battery backup time. So here the basic formula: backup time is equal to backup time is equal. So here the backup time in hours, time hours is equal to battery into battery capacity into, so battery capacity here ah is nothing but ampere hours into battery voltage into efficiency load power. So this is the backup time, basic formula of the battery backup time. So what is that? So basic formula for battery backup time: so backup time is equal to battery capacity into battery voltage into efficiency load power. So these are the battery backup formula. Next, here terms explained. So we are explaining some terms. So what is that battery capacity? So the battery capacity we are taking in only ah is nothing but ampere hours. So here ampere hours rating of battery. Next, the battery voltage. So battery voltage example, 12 volts, 24 volts, or etc., or below also we are taking here. Some of the batteries 6 volts, 10 volts. So here I am taking the example of a battery voltages 12 volts and 24 volts. Load is nothing but power. So here the load, total power consumption appliances. Next, efficiency. So the battery efficiency usually 0.8 to 0.9, so that is 80% to 90% only. Next, power factor improvement methods in electrical installations. Basically here power factor improvement methods. Power factor improvement methods, basically three things. So what are the first one here? I am taking first one, phase advancers. Second one, synchronous generators. Synchronous generators. And third one, synchronous generator, synchronous condenser. And third one, so third one is nothing but for capacitor. capacitor of motors. Okay, so these are the three things. Okay, now we are discussing power factor improvement methods in electrical installations. So power factor is the ratio of the real power to apparent power. So that is kW by kilowatt hours by kVA, kilovolt amperes. So it is that. Next, power factor. So power factor cos phi is equal to kW by kVA. So low power factor leads to high current. Next, and it is increases losses too. So losses is nothing but I square into R. I square R losses. So that is poor voltage regulation to higher electricity bills. So the main methods of the power factor improvements here, static capacitors. Now first I'm taking here static capacitor. Static capacitors is also called as shunt capacitors. So here the shunt capacitors most commonly used method. Capacitors are connected in parallel with load. They supply leading the reactive power and reducing the lagging current. So these are the static condenser or static capacitor purpose. So what is that? Static capacitor is also called a shunt capacitor. Mostly common used method. So capacitors are connected in parallel. So with the load, they supply leading reactive power, reducing the lagging current. So this is the first method of the static capacitor. Static capacitor or static condenser. So what are the applications of the static condenser? So here the applications, basically here we are the static condenser used in industries, homes is nothing fans, motors, and distribution systems, electrical distribution systems. And advantages, it is low cost and easy installation and low maintenance. So these are the applications and advantages. So here basically applications and advantages. Okay, so here applications. So it is used in industries and home appliances and EDS. So EDS is nothing but electrical distribution systems. So next, advantages. So advantages, we are seeing advantages. It is first one, low cost, and the second one, so it is easy to installation. Easy to installation. And last one, so low maintenance. Okay, so these are the applications and advantages of the static capacitor or static condenser. Okay, next, synchronous generator, synchronous condenser. So here the synchronous condenser, a synchronous motor running without an load, without mechanical load, and it is over excited, supplies leading reactive power. So this is the purpose of the synchronous condenser. So what is that? A synchronous motor running without load, without mechanical load, that is over exciting. So over exciting, then it supplies leading reactive power. So that is the purpose of the synchronous condenser. So next, similarly, we'll see that applications and advantages. See that applications. Here the applications and advantages. So here applications. So this is also we are using large industries. First one, large industries. We are discussing very few applications and advantages. Large industries and power systems. Okay, so these are the applications. Next, advantages. It is in smooth power factor control. Second one, so it can improve that voltage regulation. Voltage regulation. Okay, so these are the advantages and applications. Next, last one, phase advances. So phase advances, it is used for induction motors and it provides for excitation to rotor and reducing the larging current from supply. Next, so basically these are the three methods. Suppose if we want more additional practical methods, so that is first one, proper load management. Proper load management. Second one, avoid running motors at high load, at light load. Motors at light load. Third one, use properly rated equipment. Okay. So these are the additional practical methods of the power factor improvement methods. So in that first one, additional practical methods, proper load management, avoiding running motors at light load, use properly rated equipment. Next, so use of high power factor equipment, so replace of old motors. So in the previous what we have used that, so that is old motors with energy efficient motors, use LED lighting instead of fluorescent lamps. Okay, thank you.